Welcome. This video is a continuation on the lecture videos on counting. We're going to delve deeper into permutations and combinations here. By the end of the lesson, you will understand the difference between a permutation and a combination and be able to use them in appropriate cases. First, let's begin with the definition of a permutation. The number of ordered arrangements, that is, the number of ordered selections, of n distinct items is called a permutation. And we were using this without quite defining it yet in a previous video. Now let's prove this. Oh, excuse me. I should say what we're proving. This can be done in n factorial ways. Not only is it called a permutation, but it's written as n factorial equals n times n minus 1 times all the way down to 1. So it's the product of all of these. Now let's prove it. There are n ways to select the first item. There are n minus 1 ways to select the second item. There are, and we can keep going in this manner. There'll be n minus 2 ways to select the third item, and so on, until we get to the second and last item. In that case, there are 2 ways to select the second to last item. And finally, there is 1 way to select the last item. By the product rule, this means there's n times n minus 1 all the way to 2 times 1 ways to permute these n objects. An R permutation counts the number of, again, ordered selections. This time, instead of the entirety of the n distinct things, we're just going to look at R out of the n distinct things or items. And let's prove it. So by the previous definition, there are n factorial ways to arrange the n distinct objects. But we did not want to permute the entirety of the n objects. We only wanted to permute R of the objects. How many objects did we have left over? We had n minus R objects. And you may be thinking, well, why does this matter? You mentioned overcounting, and suddenly we're talking about what's left over. Well, this will help us figure out how much we have overcounted by. There are n minus R items remaining, so we have overcounted by n minus R factorial. Now we can invoke the division rule that we've looked at before. So if we think there are n different ways to complete our procedure, but we've overcounted by d, say, ways, then the division rule tells us to divide n divided by d. So in this case, using the division rule, from the last video, there are n factorial over n minus R factorial ways to permute R distinct things out of n distinct items. To permute R things out of n distinct items. We can further simplify this by writing this out as n times n minus 1. And I'm not going to finish my numerator quite yet until we get to the denominator, and you'll see why in a second. And we're all going to need a little more space here, so let's move that over. In our denominator, we have n minus R times n minus R minus 1 all the way to the second and last item and the last item. What do we have in our numerator? Well, in our numerator, at some point, we're going to get to the last item and the second and last item. But before that, we should get to n minus r. Well, what is the one number before n minus r? So what is the number preceding n minus r? Well, that's n minus r plus 1. So again, in our numerator, we go from n to n minus 1 all the way to the second and last item. So there are two ways to count that, and one way to count the last item. And then in our denominator, we started at n minus r, and again, we end up multiplying all these out till 2 and then 1. And in our numerator, we will eventually hit n minus r, and right before that, we multiply by n minus r plus 1. Well, this simplifies really nicely since all of these will just go away. And by go away, I mean they'll divide, anything divided by itself is 1, so we'll just multiply by a bunch of 1s at the end, so nothing changes. And this becomes n times n minus r, times n minus 1. And then multiplying all the way to n minus r plus 1.